Welcome. We've discussed circles, which we defined as sets of points that are fixed distance from a center point. Ellipses give us a way to generalize circles by allowing for an oblong structure. Ellipses generalize circles by allowing for an oblong structure in one direction. So let's give the mathematical formula for ellipses, then I'll relate them to circles. So we look at things like x minus a squared over c squared plus y minus b squared over d squared equals 1. So let's try to interpret this. So a comma b is the center of the ellipse. So just like circles, ellipse has some sort of prioritized point at the center from which we're going to measure certain quantities. Now, but c and d, what do these mean? Well, these are going to determine for us how the ellipse is stretched compared to a circle. Now, before we get to some specific examples, I want to relate this definition to the definition of a circle. So suppose that C was equal to D, and they're both equal to some constant r, which will be suggestive of the radius for a circle. This is intentional, because in this case, the formula for the ellipse, x minus a squared plus y minus b squared, c squared divided by d squared equals 1, this becomes simply x minus a squared over r squared plus y minus b squared over r squared, and this is equal to 1. So it's the same denominator for both of these. And this yields x minus a squared plus y minus b squared equals r squared, which is just the formula for a circle of radius r. So in the special case for ellipses that c and d are equal, we get exactly the formula for a circle back. Of course, this is not the interesting part of ellipses. Ellipses are mainly interesting when c and d are different and we have some stretching in one direction or another. So let's look at a first example. We'll plot x squared divided by 4 plus y squared divided by 9 equals 1. So in this case, our center is at the origin. C is equal to 2 and D is equal to 3. A nice way to get started with these things is to try and plot a couple points on the ellipse. And an easy way to do that is to say set x equal to 0 and set y equal to 0. So if x is 0, then I have y squared divided by 9 equals 1. So y is equal to plus and minus 3. If y is equal to 0, then I have x squared divided by 4 equals 1. And this implies that x is equal to plus and minus 2. And with this information, I can actually draw a pretty good plot of the ellipse. So let's draw some axes. And now we'll put these points that we determined. So when x is 0, y is plus and minus 3. So here's a point, and here's a point. And when y is 0, x is plus and minus 2. This is x. So these are points on it, and we see that I get this nice football shape. And it's stretched more in the y direction than it is in the x direction. It's stretched by a factor of 3 in the y direction and by a factor of 2 in the x direction. This makes sense because I have a 9 here versus a 4. This is bigger. So I'm allowed to have bigger values of y. And in fact, if the d is greater than c, then the major axis is the y-axis, that we're stretched in that direction. So in this case, d is greater than c, which implies stretching in the y direction. And we give a special name to this. We would say that y is the major axis. And x would be the minor axis. If c was greater than d, then we would say that x is the major axis. So this idea of major and minor axes is just a way to say, in which direction am I really stretching? Now, there's one more interpretation of an ellipse that might be convenient for us, which is to think about it in terms of sets of points, fixed distances from other points. So this is similar to a circle. We wanted to define a circle as a set of points, a fixed distance from the center. Here, that doesn't make sense for an ellipse. This point is distance 3 from the center. This one is distance 2. So I'm not going to get away with defining an ellipse as the set of points a fixed distance from one point. But I can use 2 points to make this happen. So I can consider an ellipse as a set of points a fixed distance from 2 points. So the emphasis on 2 compared to 1 for a circle. And these are called the foci, the plural of focus. So we can compute the foci in the following way. Given our formula x minus a squared over c squared plus y minus b squared over d squared, we have 2 cases. If c is greater than d, then the foci are a plus and minus the square root of c squared minus d squared, comma b. And if d is greater than c, we get a comma b plus and minus the square root of d squared minus c squared. So let's use this in an example. I want to look at a more complicated ellipse, plot it, and also plot the foci. So let's plot x minus 1 squared divided by 16 plus y minus 2 squared divided by 25 equals 1. So let's see here. Where's the center? It's at x equals 1, y equals 2. And we can play the same game as before. Let's say that x is equal to 1. In that case, y minus 2 squared needs to be equal to 25. So y minus 2 equals negative 5, positive 5. So y equals negative 3 and 7. And now let's say if y is equal to 2, then I need x minus 1 squared to be equal to 16 So x minus 1 equals negative 4 and 4. So x equals 3. Negative 3 and positive 5. Yep. So let's plot these points. So when x is 1, y will be negative 3 and positive 7. So something like there. And when y is equal to 2, x will be equal to negative 3 and also positive 5. So the picture is something like this. Approximately. Now, we can also compute the foci. So in this case, what is bigger, D or C? So D is greater than C here because this is 5 and this is 4. So our foci will be A, which is 1, and then B, which is 2, plus and minus the square root of 25 minus 16. So 1, 2 plus and minus square root of 9. So 1, and when, let's see, so negative 1, the negative branch, and 1 comma 5. So we're sitting like there, and then also there. So those are my two foci. As a last comment about ellipses, you may be asked to compute the area of an ellipse. The area formula is rather simple. It's simply, well, what was it for a circle? Let's think about that. It's pi times r squared. But here I don't have one radius. I sort of have two. One for C, one for D. So this is out, and we'll say it's pi times CD. So each of the directions I get pulled in contributes equally in this product. So in this case, C was 4 and D was 5. So in our case, the area is equal to pi times 4 times 5. So 20 pi. So what should you know about ellipses for the CLEP exam? Well, you should certainly be comfortable with the basic definition and how to plot. You should have an idea of what the foci are, and you should be able to compute the area. One comment is that it is not so easy to compute the perimeter or the circumference of an ellipse. This was easy for a circle, but it's actually quite a difficult calculus problem. If you decide to move forward with advanced mathematics, you may spend some time on it. It even has connections to very theoretical subjects like number theory. But unfortunately, it's beyond the scope of this exam.